Let's do section 9.4, page 471, exercise 3, which reads, A, express the improper integral as a limit of definite integrals, and B, evaluate the integral. And for exercise 3, we have the integral from negative infinity to infinity of 2x over x squared plus 1 squared dx. One of the things we're supposed to be learning in this section is that we can't have plus or minus infinity as the limits of our integral. And this is what is called an improper integral. And the first definition in this section tells us how to deal with this. Now, because we have both negative infinity and positive infinity as our limits of integration, we have to take an intermediate step here and make this the integral from negative infinity to some value c of 2x over x squared plus 1 squared dx, plus the integral from c to positive infinity of 2x over x squared plus 1 squared dx. Now, we still have plus or minus infinity in the limits of our integrals, but now we can deal with them using parts 1 and 2 of the definition for improper integrals with infinite integration limits. And c is just any real number between negative infinity and positive infinity, and I'm going to let c be equal to 0. So let's rewrite this, and now what we're going to do is substitute in a variable, a and b in this case, for the plus or minus infinity, and we'll set it up with a limit. So this is going to become the limit as a goes to negative infinity of the integral from a to 0 of 2x over x squared plus 1 squared dx, plus the limit as b goes to positive infinity of the integral from 0 to b of 2x over x squared plus 1 squared dx. And now we're ready to take the antiderivative. And to do that, I'm going to need to make a u substitution. So I'm going to let u be equal to what's in the denominator, which is x squared plus 1. And then du is going to be 2x dx, which is what we have in the numerator. So we can rewrite these again as the limit as a goes to negative infinity of the integral from a to 0 of u to the minus 2 du, plus the limit as b goes to positive infinity of the integral from 0 to b of u to the negative 2 du. And of course, we know how to take the antiderivative of u to the negative 2. So I'm going to have the limit as a goes to negative infinity of u to the negative 1 over negative 1, evaluated from a to 0, plus the limit as b goes to positive infinity of u to the negative 1 over negative 1 from 0 to b. So now we need to substitute back in for our u. So we're going to have the limit as a goes to negative infinity of negative 1 over x squared plus 1 from a to 0 minus the limit as b goes to positive infinity of 1 over x squared plus 1 from 0 to b. And now we can just substitute in our limits like we normally would. So this is going to give me the limit as a goes to negative infinity of negative 1 over 1 minus negative 1 over a squared plus 1 minus the limit as b goes to infinity of 1 over b squared plus 1 minus 1 over 1. Well, when I actually substitute in for a and b, when I'm evaluating this limit, this term is going to go to 0, and this term is going to go to 0. So I'm going to end up with -1 minus -1, which is going to give me 0.